Gentlemen, thank you so much for joining us.
Thank you.
We're here, you said backstage, Jordan said we're here to talk about cars, but you said trucks.
That's right.
Yeah, your company does trucks, and then Aurora, of course, does cars.
We do cars and trucks, yes.
Yeah, it's really interesting because both of your companies are addressing autonomous vehicles, but different markets. But at the same time, you both have one concern, which is safety. It was kind of funny because 2 years ago this month, an Uber self-driving car struck and killed a pedestrian. What has changed in the market since then?
I don't know that I would say the case for safety has changed. Like, it's always been pretty absolute, right? You're trying to focus on building a driverless platform that you can produce a functional safety case with a strong pedigree. And you demonstrate that internally to your own processes, and then you demonstrate that to regulatory satisfaction, and then ultimately, it is the public that we need to satisfy that we are building safe vehicles that they can trust operate around them.
Obviously, you're not with Uber, but how did that incident change Aurora's outlook on safety?
I can't really say because I was not at Aurora at the time. But Aurora has always been founded centrally with a core belief in safety. Like, the mission is to remove the driver, and in order to do that, a lot of the challenge comes around not just how you build a system that performs well, but how you actually validate that system is safe in its performance. And so, Aurora's mission statement is to deliver the benefits of self-driving safely, quickly, and broadly. And they were very careful about choosing the ordering of those statements. That safety will always come first, and that we are willing to take more time. We are willing to delay the emergence of true self-driving vehicles to really build a safe and validated platform.
Yeah, so to go back to your first question, it was like, what has changed in the market? I have seen, I think, a shift in the space in terms of how to approach the technology. So when we founded Ike, it was not like, how can we get a prototype on the road as quickly as possible, but like, what does it actually take to safely deploy a product on the road, on the public road, and what does it take to build that, and let's build that. So that kind of shift you've seen broader, I think, and Aurora is an example of that as well. Where there is just a different approach to developing the technology, and I think that is partly motivated or reinforced by what happened at Uber at the time.
Right. So Ike does long distance trucking.
Correct. Yeah.
Where does pedestrian safety or other driver safety come into play with your company?
Yeah, no, it's of course amazingly important because we are doing trucks on the highway. That is our core domain. So we are not envisioning transporting passengers ourselves. So the safety case is always with respect to the other participants of traffic. So yeah, that's front and center, obviously. Like, they need to be safe. Yeah.
Both of your companies rely heavily on simulation for safety testing. What points do you look for to say, okay, it's safe now in the simulator, we can take this on the public road? What do you look for?
So our kind of virtual testing is largely safety is one component, but it kind of underpins the entire program. A lot of that is around how we develop quickly, how we are able to kind of explore the space of solutions, and so we look at it as it's very important to move quickly and to try a lot of different things and to empower engineers to run a lot of different experiments. And you're always going to be slightly constrained if the only environment you can test that on is on public roads, or even in private tracks. You still have to worry about certain limitations of your solution. And so with virtual testing, you kind of open up the exploration space to try a lot of different things, and you can also you get a lot of feedback very quickly about corner cases and edge cases. And so a lot of what we do is really allowing rapid iteration and rapid feedback, and then doing that in a way that provides us confidence that we shouldn't have any new findings on road. And where we do have new findings on road, when something slightly unexpected happens, or we'd have a disengagement because we would take the vehicle operator, the safety operator would take over. We always roll that back in, right? So into our virtual testing. So, I mean, this model is fairly common in lots of industries where when you don't have the ability to do full scale testing, is that you are building. You build a virtual environment, you build a simulated environment, and then you are constantly using real-world learnings, either as subscale, subsystem testing, or full-scale testing, and rolling that back into the fidelity of simulation.
What about it, Ike?
Yeah, so of course we all know that if something does not work in simulation, it will for sure also not work in the real world. If it does work in simulation, it may work in the real world, right? So we use simulation like throughout and the software and hardware in the loop as well to test all of our development and quickly iterate. It's basically the same idea across all components of the system. And only when we have worked through the simulation and the simulation works really well, we may want to test it on a public, on a private test track. We have not gone on public roads. Because for the development of our technology, that is not necessary, and it incurs a lot of risk and cost to do that. So we really focus heavily on simulation, and we have private test.
What platforms do you use for simulation? Are they off-the-shelf solutions, or did you develop them in-house?
We develop our simulation house. We believe that it's so core to our mission that we need to own it ourselves. So we have a phenomenal simulation team that allows us to test every aspect of the software in simulation very thoroughly across a wide range of situations that the vehicle may encounter.
You're nodding over there.
Yeah, I mean, I completely agree with that approach, obviously. So all of Aurora's simulation has been developed in-house. And it's hard in vehicle autonomy, you want to be making progress early, you want to be getting vehicles on the road that demonstrate the credibility of the program. But it takes a while to build a simulation program. And so Aurora from the beginning has been building this simulation program. And so you've really seen over the last couple of years, as our simulated miles have started to increase exponentially, to the point that we are very, very kind of prescriptive about where we use on-road automated driving to be kind of feeding back and building confidence in the fidelity of our simulated system.
A lot of people out in the audience there are probably thinking the simulation is incredibly expensive up front. Are there any solutions that they could use to bring similar things in-house to their companies?
Well, of course, there does exist like companies that provide simulation solutions to other companies that they can readily use. We have deliberately made the choice not to go that route, but then to build it ourselves. Again, because it's so important and so critical and core to our mission that we need to own that technology.
Sure.
And it is very important. We have built that from the very beginning. Let's focus very heavily and invest very heavily on building a simulation system. And we have not first gone to the public road and then built a simulation system, but the other way around. And if we go on the public road, we will do so only after we have confidence from our simulator and the private test tracks that we are really ready to do so, and that we can safely deploy it. Of course, at first with a safety driver, but that we can actually go on the public road and not cause any risk to the public.
No, we were talking with my staff about this, and somebody brought up an interesting point that young drivers have to do a driver's test, and that's a standardized test. Should there be a similar test for autonomous vehicles?
I believe so. That would be great.
Yeah, I mean, I think we collectively, both at a regulatory level and as a societal level, we need to have some agreements around what constitutes a safe system. So I always pause because I worry a little bit about, like, one performance does not make a platform. Like, I have a daughter, she's 15, she's going to get her learning permit quite soon, and she will, at some point in the next couple of years, be able to pass a driver's test, and that will just be the beginning, right? She will not be a safe driver having passed that driver's test. And so, when you look at at various industries that build safety-critical systems, you have to think about holistically how those systems are built, and so I think there is, the foundations of what will make a autonomous vehicle without a safety driver both safe and performant. One of those things will be like practical demonstrations, but I think the process and production of the software and the way the hardware is developed will also have to come under scrutiny.
So
Yeah, I think there will be quite a few challenges in that. Like, of course, there needs to be a definition of what constitutes safe. Like, we, of course, define our own definition, but Aurora does it too, and there may very well be differences there. So somehow there must be some kind of understanding across the industry about what that is. And then the second challenge is, okay, how do you then test, like, if there is some kind of standardized test for whether you actually
well,
make
who should
safety.
build that test?
Exactly, that is a big question, of course. How that, I don't know how that is going to play out, but I very much believe in the philosophy of that approach. So we are doing that in-house and based on our own definitions of safety and what it constitutes to pass that test. But it would be great, I think, in general, to have regulatory guidance as to what a safe vehicle is and what acceptable risk is.
What do you think the current regulations in place are robust enough to handle the onslaught of self-driving vehicles?
No, there is virtually nothing at the moment, right? There needs to be some kind of definition as to what does it mean for a system to be safe. Like in our particular case, driving on the highway, what is the probability that the occurrence rate of, let's say, the vehicle departs the lane or something like that. That must be a very, very low number, obviously, but that number needs to be defined somewhere, I believe. And we can make our own number of that, but if that is some kind of and this is just one example, but if there is regulatory agreement on what that number is, and then we can test towards that number, that would be helpful, right?
Sure.
If we all held to a common standard across the industry.
Yeah, I think it will be an active partnership, both amongst within industry and with regulatory bodies.
Yeah. But it's not going to be easy because, of course, there's a lot of intellectual property associated with what constitutes a safe system. Like if somebody knows what a safe system is, then that is extremely valuable. We believe, of course, that we have a good idea of what that is, but and other companies may not want to share that with each other. And so there is going to be some challenge how this is going to play out. It's going to be interesting how this will evolve.
Both of your companies have been in testing for a while. Let's talk about deployment. When are these going to hit the roads? When's the first long-haul trucking system going to happen?
That's the million-dollar question, of course. When? Well, when we are ready to do so, right? And we need to build a safe system and that meets all of the requirements that we have. And our approach generally is like we have a single fault-tolerant system across hardware and software that needs to be built, and then we have requirements for all the sub-level components that need to be validated, and then we need to validate on the system level that we can safely deploy the vehicle on the road. And if that is all the case, then we will deploy the product.
Well, take me through the how Ike works, or the solution you're going to provide.
So we have requirements like across the components of the system, like what they need to be able to do, and if we can validate that they actually do that, then we are going to deploy that on the road. And we have data in-house, but also external data about like the frequency of events that occur on the highway. There's actually a good data set for that, so that we can have an idea of like what are we likely to occur. And based on that sample and that distribution, we test our system across variations of those situations based on the statistics that are there to see, does our system meet the requirements that we set for ourselves, very high bar, and then we can deploy on the road.
What data do you have that shows that Americans are ready for trucks to cross Texas without any drivers?
That's a good question.
Thanks.
Yeah. I don't know if there is data. I think this is a question that is open to a large degree. We have to see where this goes. Obviously, if we deploy self-driving vehicles, whether that is in the city or whether it's on the highway, those systems need to be safer than a human driver, right? At least, and probably much better than that for the public to accept such systems. So I think this is going to be a process in society where the acceptance of these vehicles will increase, and at some point it becomes the norm. But how that exactly is going to shape out is not exactly clear yet, right? It is still a very new technology. So I think all of our companies are playing an active role in trying to shape that narrative and trying to educate the public onto what it means. But this can go in multiple directions, and it's, I think, our responsibility to make sure it goes in the right direction.
Great.
And that people will be accepting of this technology. And the key is really safety. Like, this needs to be safer than human drivers.
What about at Aurora?
So Aurora's focus, the focus of the engineering teams is around this product that we would describe as the Aurora driver. And so it's kind of all fun and games in autonomous vehicles until you actually build a system that can allow for the removal of the safety drivers. as we are developing this product, we're building it to be applied to multiple different businesses. And so the critical focus is around building partnerships. Like, we want to build something that can be fielded by other organizations. We want to empower and augment other companies and industries.
Like what?
And so in logistics and people movement, we want to build the Aurora driver, and that's the focus right now, is building both the driver and defining the platform that driver can be applied to, and again, like what redundant components are required for this system to be controlled safely, so that we can apply the Aurora driver both to the movement of goods and the movement of people. So, you know, we're integrating this. We've integrated this with a passenger sedan. We're integrating with a passenger minivan. We've integrated with trucks and with panel vans. And so we're constantly building this system that can be kind of adaptable to lots of different vehicles and lots of different businesses. And then, like, we're not necessarily trying to field this product as a business we own. We are trying to partner with others who can then use this to augment their business.
Is the current technology in the market good enough to make that goal possible?
Well, I mean, prior to Aurora's acquisition of a LiDAR company in Bozeman, I would have said it needs more time, especially at highway speeds with high control latencies, like, you know, large braking distances, large stopping distances for large vehicles. The range of a multimodal system that you want to apply for LiDAR, camera, radar, I would have said it needs more time. And so since we have brought a FMCW LiDAR in-house, it really has been a game changer for us in what we believe how we can operate with excellent perception at range, and demonstrate a validated safety case around that.
Tesla says, or people say, that Tesla is 6 years ahead, and you're smiling. Tesla says that they're 6 years ahead in technology. What do you guys see?
Well, Elon Musk said that it would launch last year, I believe. So, well, I don't think so, but
Right. Well, it's not here yet.
that's right. No.
Oh, are they 6 years ahead of Aurora?
I honestly don't know that there's any way to judge the state of any given program. There's kind of there's this kind of 0 to 1 moment, right? That we're all trying to achieve in terms of when you can actually demonstrate not just that the system can perform without a safety driver, but that over the long haul is trustable. And you know, it's hard for me. Like, I worked with the Tesla team. I think they're great people.
Right.
And we're all kind of we're all coming at the problem from different backgrounds.
Well,
and
for
different
instance, they don't use LiDAR, right?
No.
Is that the correct way to do self-driving cars?
So
I'm trying to get you to talk shit about Tesla.
No,
is what
I would
I'm trying
never.
to do.
No, I mean, I seriously would never. Like, I have a tremendous amount of respect for them. What I would say is the most interesting challenge that I see right now is around motion planning, is around, once you know what's in the world, how do you decide how to do something reasonable and safe in that world? And you know, right now we have a lot of roboticists here, and getting a sufficient ground truth to make motion planning decisions is usually like the first hurdle. And so LiDAR allows us very very quickly to focus more on the motion planning problem. We get to the starting gate of the motion planning problem, and really allow that team to explore the space very deeply. At the same time, in parallel, that we focus on the long-term, long-range performance of a multimodal system. So, I think you can absolutely solve this problem with cameras only, but it's a matter of how you want to break down the problem and in what time frames you want to be tackling what parts of the challenge.
Yeah, I think what's interesting about their approach is that they've really basically taken an L2 system and kind of gradually like improving that according to their approach to get maybe to L4 at some point. And my view is that in the middle of that transition, you cross some kind of uncanny valley where it's not clear like who is in control, and that creates, in my view, a very unsafe system where people start to trust the system even though the system cannot be trusted, and then you have these accidents that actually already have occurred. I think what I find amazing is that Tesla has been able to somehow got away with that, and that's what they're doing very well. Somehow, right, like it doesn't stick to their brand as much because they had a few accidents as well.
Right. Well, I guess the question is, how safe is too safe, right?
Well, I think you need to jump to the L4 like at once, like you not go through this valley where it's not where the system feels safe, and it's safe like 99.9% of the time, but in the case it's not safe, it suddenly is very unsafe, right? It needs to be really be safe all the time, and where you can really rely on the system and not rely on the operator anymore. And that in that gray zone in the middle, that is potentially very unsafe, I think. But I mean, they're doing it, so and they're doing pretty well with it, it seems. So
well, only a few people have died.
Yeah.
Oh, okay, all right. Let's get back to technology. I asked Jenna this earlier, but technology, what would change for Ike if you had better technology, or what's missing for deployment?
No, I mean, to this point, like about LiDAR, like when we started, like the range of the LiDAR was like you had Velodyne, and that could not see far enough for our application on the highway, but like there were, at the same time, there was an enormous growth of number of companies that do LiDAR, also at long range, and so the timing for us was perfect. Like that technology is now maturing, and that is what we will be relying on, like long range LiDAR. And of course, that's the better that becomes, the better we will perform.
Right.
But like I think in terms of timing, it's great because I hope by the time we are ready, then they will be ready too, and that it converges nicely.
What about 5G?
Yeah.
Does that change the equation for your solution?
Potentially, because 5G, the promise is that the latency of the connection is low, and that would allow more so than today, like remote control perhaps, or very high fidelity remote assistance. So we are at Ike keeping a close tab on what is happening with 5G, and if that indeed fulfills the promise, then we may exploit that technology for this particular purpose for our product.
We only have a couple minutes left here, and talent recruiting is a big thing right now in your industry. How does small startups like yours recruit against Tesla or Argo or General Motors? What do you bring to the table? What do you tell these people? Why should they come work for you?
Well, we are still really small, I believe, like compared to.
Well, they're a little bigger, but you're very small.
Yeah, so that's the excitement of it, right? Like everybody who works for us has an enormous amount of ownership into the problem. You have a visibility into the challenging problems, a lot of visibility into how a company is run, and people are close, and the communication links are short, so there's not overhead in terms of bureaucracy, etc. So it is an enormous amount of fun to work at a startup, and you learn an enormous amount compared to a big company. I've worked for big companies, and I would recommend to anybody, even if not for Ike, go work for a startup. That's where you learn the most, and where you have really where you see the most, and work with senior people as well as your peers, and it is just an awesome experience.
Are you hiring right now?
Of course. Yeah.
What are you looking for?
Across the board, engineers, but also policy and product. Etc.
What about at Aurora?
We have a stand upstairs, so if you're interested, then please come meet us.
Yeah, if you need a job.
So in any job search, right? I think I focus strongly on our engineering recruiting, but obviously Aurora is hiring across many different disciplines. But especially for engineers, it's usually this exploration of trying to find an alignment between mission and peers and then the overall value proposition, right? So most of the people who come to Aurora kind of self-select for the mission, and that makes for a very exciting place to work. When people are mission aligned, it cuts through a lot of the noise and debate about engineering solutions, and kind of breeds a broader trust within the group. And then what people find when they come to Aurora is also that like we have a very tight knit and as small as we can get away with. High talent team, right? So we tend to hire very experienced people, very senior people, to try to allow our teams to stay as small as we can get away with while tackling enormous problems. And so that allows for a lot of interaction between really, some of the top minds in these fields, and so it's a very attractive place for people to come at various levels of career to be a part of this and be exposed to this, and like we tend to be a fairly humble and somewhat introverted organization of engineers, but everyone's super generous with their knowledge and their time with each other. And I think that really, that's frequently where we win in competition with other people in the market, is the creative and learning environment that we can provide. And then obviously, you know, the overall value proposition is important to everyone. So kind of where the kind of what people think they can accomplish, what they think they can learn, and what the overall value to them will be for their time at Aurora. We're
out of time, but I'm going to steal one more minute. I had questions about SpaceX, because you just came to Aurora from SpaceX after spending about 10 years at Google.
Yeah.
So I guess the last question is, who's a better boss, Chris Urstman or Elon Musk?
I love everyone I've ever worked for.
I mean, like Jordan will stay back there.
They've all taught me. No, they've all taught me like a tremendous thing, a number of things that I never knew. Right? Like I've grown deeply under just about every boss I've ever had.
I've worked for Chris Urmson. He's great.
There we go. We'll take it with that. Yeah. Well, thank you very much, guys. I really do appreciate it. Give them a round of applause.
Thank you.